All right, welcome 8th graders. This is Big Idea B review for the ISN. And there are basically two questions to it. One's a little bit crazy and the other is a little bit more scientific. So to start off with the crazy one, do aliens really abduct people? And I think the question really was answered with the video that we watched just a few days earlier, in which we found out that there are actually lots of reasons why you shouldn't believe in alien abduction stories. There were 5 main reasons, and if you've made your alien brochure or your cartoon, you probably are pretty familiar with these 5. There's no physical evidence. There's never a sign that anyone's had like a tracking device implanted in their nose or any other physical marks, scars, or anything like that. The symptoms that alien abduction people talk about are the ones identical to sleep disorders, like hypnagogia and sleep paralysis. So people feel like there's someone else in the room with them. They feel like they can't move, a feeling of like a weight on their chest, feeling like they're floating, seeing flashing lights. All symptoms that abduction people talk about, and all symptoms of sleep paralysis and hypnagogia. Besides that, there's also false memories. And we found out in the video they're very easy to implant. All you have to do is just basically sound very convincing and ask people to remember something from way back. And according to the study they did, about 25% of us will come up with a false memory. Also, hypnosis is very, very unreliable. If you can hypnotize someone and get them to think that they're a chicken on stage for entertainment, you can hypnotize someone and get them to think that they were abducted by aliens. And then number 5, it's impossible for human DNA and alien DNA to combine into something that actually could be viable and that could survive. We can't even do that sort of a thing here on Earth. The only other DNA we can mix with human DNA is human DNA. And so it doesn't work with aliens. So that's the first question, B1. And that was an easy one to answer. The real question is, are there aliens out there? And can we communicate with them? Real aliens. And so if you recall, we talked about how would you go about actually finding out the real chances? So there was a person who actually tackled this problem of intelligent life. His name was Drake. And he went about trying to find at least a scientific way to guess at how many intelligent alien civilizations there could be. And the thing to remember is this is guesswork. Until we've actually gone to all of these planets and made these discoveries, what we're doing is we're making our best guess. So if we're going to make the best guess, let's do a good job of it. The first problem is figuring out how many stars there are in our galaxy. And roughly, there are about 200 billion stars in our galaxy. And so next the problem is if that's how many stars there are, how many planets would there be? And if we use our own 8 planets as kind of a way to guess, we could do that, but then there are over 100 different moons, and moons could carry life. There are dwarf planets in our solar system. So Drake decided to guess a really low number. Instead of hundreds, he guessed 10. So the average star system should have 10 planets around it. And that also makes the math pretty easy, because if we have 200 billion stars and each of them has 10 planets, you don't even need a calculator for this one. You just add a 0. We're talking about 2 trillion different planets out there in our universe. But that doesn't mean that every planet's going to have life on it. There are 2 trillion planets, but some are going to be too cold, some are going to be too warm, some are going to be gas planets, and that doesn't work so well. So how many worlds in our solar system could have the right conditions for life? If we use that as a basis, then maybe we can come up with a reasonable number of planets in every solar system that would. And when you think about it, obviously the Earth, but Venus could have the right kind of conditions if its atmosphere was better, if it didn't have so much carbon dioxide. Mars would be better if it had carbon dioxide. So there are actually 3 planets in the Goldilocks zone around our star. And then there's a handful of moons that actually hold some possibilities too. What Drake decided is he said out of every solar system with 10 planets, 2 would be the right distance, have the right kind of conditions for life. And so what you need to do is find a way to whittle that number down. If we think that there are 2 trillion planets, could we then divide by 5? And the reason we're dividing by 5 is 2 out of 10 is 1 over 5. And so we're not dividing by 2, we're dividing by 5. And actually, you can cheat a little bit and make the math way easier. 20 divided by 5, you probably know, is 4. And since we covered up all these zeros, let's see, 11 of them to be exact, We just need to throw those 11 zeros back into the answer behind the 4. So it turns out that there are 400 billion planets that could have the right conditions for life. That's a lot. But even that is not our final number, because just because you have the right conditions doesn't mean you're actually going to have life. So we have to whittle the number down more. And so Drake decided that out of 400 billion planets, about a third of them actually would have life on them, and the other 2/3 wouldn't have it. So it's math time again. We take 400 billion, and this time we're dividing it by 3. And if you do the math, it turns out to be about 130 billion planets. Quite a bit less than the 400 billion, but still 130 billion is a pretty big number. And those are planets that actually do have life on them. But having life isn't necessarily a guarantee that we're talking intelligent life. So we're not interested in the bacteria that are out there. We're interested in the civilizations that could communicate with us. So Drake had to whittle it down again. Out of every 100 planets, only 1 was going to have intelligent life, according to Drake. So very small number. He wanted to really estimate low. So if you assume that 99 out of the 100 don't have intelligent life, and 1 out of 100 do, that means we have to divide this by 100. And you don't need a calculator for this. Any number divided by 100, you just drop 2 zeros. So this is an important number right here. 1.3 billion intelligent alien civilizations in our galaxy. That's the current estimate. But that's just one galaxy. What happens if you consider every galaxy that's in our universe? The low estimates are about 20 billion galaxies in our universe. So, do the math. 20 billion galaxies, if each of them has 1.3 billion alien civilizations, we're looking at a number of around 26 quintillion alien civilizations in the entire universe. You could write that number, but that number is pretty sweet too. 2.6 times 10 to the 19th power. That's 26 quintillion alien civilizations. It's a huge number, mind-boggling number, and yet that's not even close to a Google. A Google would be 10 to the 100th power. So it's still a long ways off from a Google, but a large number. If we look at this from another direction then, if the universe is busting at the seams with intelligent life, could we contact them? Well, you got to consider travel time. Alpha Centauri is 4 light years away. It would take you 4 years at the speed of light to get there. The opposite side of our own galaxy, 100,000 light years away. Take you 100,000 years at top speed to get there. The local group galaxies, 200,000 light years to all the way out to 2 million light years just to reach the galaxies within our local group. And the edge of our known universe, that's 15 to 20 billion light years. So, and that's at the speed of light, and we actually can't get anywhere near those speeds. So sending a spaceship to contact aliens on another planet, bad idea. Too far away. It would take us tens of thousands of years to get there with our current technology. You can't send a space probe because the same problem. It would take tens of thousands of years, and a robot, even the best built ones, aren't going to last that long. But what you could do, send a message. Well, you could send a message at the speed of light, but it would take so long to hear back, And how long do you wait? Do you wait 10 years, 20 years, 100 years before you hear back? So that's a very ineffective way. The most effective way is to listen for them. Using radio telescopes, we listen for intelligent signals out there. We're sending out radio and television transmissions right now as we speak, and those are spreading out throughout the galaxy. So what if we listen for other civilizations? And so that's where SETI comes in. SETI is the Search for Extraterrestrial Intelligence. It was developed in the 1970s to search different sections of the night sky for radio signals. And wouldn't you like to know who founded SETI? That would be our very own Carl Sagan. But a few things to think about here. Radio frequency. What radio frequency do you listen to for SETI? What if you're looking in the wrong part of the sky? What part of the sky do you look at? Will our own radio signals drown out extraterrestrial signals? You don't want to pick up a passing satellite and mistake that for intelligent alien civilizations. And how do you deal with all of the data? And so that's SETI for you. And that's our big idea B. And really the big idea is the universe is teeming with life. We are definitely not alone. So good luck for you on your quest here for your ISN. And we'll see you again for Big Idea C and Big Idea D reviews. Bye.